Thanks for coming out to this event. I'm going to talk to you tonight, actually not a lot about high-performance computing, but a little bit about the challenges of how a company goes from being a small company into an industry that is always changing and changing drastically, and the impact that's had on traditional IT strategies that we've employed. High-performance computing becomes one of those tools that we use to address that, but I just wanted to cover a lot of the different details of what we've gone through. A little bit about the company. It started in 1999 by 4 oil and gas pros. They had difficulty in looking up information, data. There was not an easy way to go about it. They all started in Texas. For those that don't know, there's 22 states that actually produce oil and gas in the United States. About 70% of those wells are in Texas. Out of about the 4 million wells that are out there, a little over 3 million are in Texas. What we do at Drilling Info is to collect all that data and develop a series of analytics and tools that help the upstream E&P companies make the best decisions they can with the data that they have. We do this in order to try to make things more efficient, more competitive, so that the companies, as they go out there, our job is actually to try to do the thing that we've also feared in the last few months, is drive the price of oil down. Our CEO is famous for saying, I'd like to take a billion-dollar industry, a multi-billion-dollar industry, and turn it into a multi-million-dollar industry. The way we do that is by trying to help them get more efficient. John mentioned about the oil prices. Starting in about August and September of last year through the end of December, the price of oil dropped 60%. So try dealing with an industry where your customers' value dropped 60% in less than a quarter, and how that's going to impact what you do as a company trying to serve their needs. And the way to do that is by looking at their data, by analyzing it, by really pushing for those efficiencies. Unlike a lot of other industries that do get hit by hard times, and they all go through cycles, what the oil and gas industry did was they were able to react in 2 ways. One, the service companies were able to absorb some of that price shock because they know it's a cyclical type of event. The other was they were able to develop new industry techniques inside of 3 months that lowered the average cost of drilling a well by 40%. I don't know of another industry that can react that quickly to something like that. That's where we come in with a lot of these companies, is helping them do that. So in that changing time, there's a lot of problems from those industries that impact a technology company. And I'm just going to go over a few of those. I'm not trying to be pro-oil or anti-oil or whatever. I'm just laying out some of the realities that we have to deal with on a daily basis. One, it's massive amounts of data. A single seismic study of a 1 mile by 1 mile grid is in the multi-petabyte range, just to start. When you consider that to drill a well, someone's got to take out a lease. When taking out that lease, you have to look up every mineral right owner that had that lease, and when you think that some of these were granted some 150 years ago, there's a lot of descendants you have to find. Once you have that lease, you got to rent it, you have to file a permit, you then engage with different companies to go and do the site surveys, drill the wells, complete them. All of that data has to be collected, and that's what we do. We collect that data from mostly public agencies, and this presents another series of challenges. Today, right now, our active database is about a petabyte in size. It grows at about 20 to 25 terabytes a month. In 2 years, those numbers will be really small compared to what's going on. We only have a small subset of the database in some areas. This petabyte database does not include our international database, which is about another petabyte in size that covers 14 regions internationally. The data is extremely dirty. And by dirty, I mean, in the United States, there are roughly 29,000 oil and gas companies that drill actively in the country. In our database alone, just in the company names, there are 13 million different spellings of those 29,000 company names. And that's just on the company name. That's not even into the complex data. Less than 1% of it is shared. I've worked in security, I've worked in real estate, I've worked in email and messaging systems, and I've never worked in an industry that hoards its data amongst its users as much as oil and gas users do. They actively try to hide data from each other unless, for some reason, they decide to go into a JV or a joint exploratory operation, and even then they're paranoid. They'll share as little data as possible. This makes it extremely difficult to instill into the industry things like data management, which is kind of 101 stuff. They're at least 10 years behind. It redefines the meaning of unstructured. I go to big data events and I hear, oh, we got unstructured data, and they show me a weblog from a web server. I'm like, that's not unstructured. It has column headers. You can deal with that. In oil and gas, it is not unusual to come across a proprietary database that 10 rows in, they've decided to redefine what a column means. And then 10 rows later, they've reordered the columns. And then another 5 rows later, they've just decided to overwrite column 3 with a totally different data set that never existed before. And then they write applications on top of this with all sorts of business rules in the apps. So when I say unstructured, it really is unstructured. There's no sense to it at all. It also never ages. The interesting thing is you're dealing in an industry of geologists and geophysicists who are used to dealing with rocks 300 million years old. So what's 10 years? Why do we punish ourselves this way by going after these guys? Well, like Larry Page says, we choose because we deal with data, and besides, it sounds cool. One of the other problems that is happening in the industry that we have to deal with is a big shift in the demographics. Today's average user of oil and gas software is 55 years and older. They are technically cognizant. They're not mainstream technologists. Most of them came up in school when they looked at well logs on light tables and they drew contour maps with a 10-hole ruler. But they'll use software, but they're kind of set in their ways. The software hasn't really changed much in 30 years. Then there's a big gap. My generation did not go into the oil and gas business. The next big spike is 35 and younger. And a lot of people say, well, the millennials, that's their crowd and they're tech savvy. And I'd say some are tech savvy, mostly they're tech dependent. They cannot live without technology. Watch a room full of 30 and under freak out when Wi-Fi goes down, and you'll get an idea of that. Where that presents a challenge is that in 5 to 7 years, for every 2 geologists or geophysicists that retires, only 1 is coming into the industry. So that means within 5 to 7 years, we'll have half the experts in the field. This is the second largest industry in the world, the first being food. And most of the oil and gas energy that is used is in the movement of food. And you're talking about half of the people doing that job will be gone in 5 to 7 years. So that means they have to get more efficient at what they're doing. They have to get stronger and faster. So as I said, we're dealing with 300 million year old rocks, 150-year-old records, 50-year-old techniques with 30-year-old software. And that's what we're trying to break into. So what does that mean to us as a technology company? Well, for one, our next biggest competitor, that's one up from us, is at least an order of magnitude larger in size. They are a multi-billion-dollar company. They have more people doing their PR than we have in our entire company. So that means for us that we have to outmaneuver them. Traditional IT strategies will not work. We will get crushed. That's just the way it is. Momentum and size matter in these things. The traditional strategies of having our own data center and owning our iron and doing those kinds of things were simply getting us killed. And that's how we were built. That's how the company ran for the first 10 years. So we had to make fundamental changes in how we operate in our day-to-day activities. First was, if a customer didn't pay us to do it, we stopped doing it. Now by this I mean all the back office systems. I didn't have a single client that paid us a single dime because we had one killer financial system. What we did is went through our entire system, our entire organization, and we looked at everything and we said, is someone paying us to do this? And what we found was no. For CRM, email, HR, finance, project tracking, and travel, those weren't our core operating pieces. Nobody was paying us for them, so we started pushing those out. So we moved email to Google Apps. We moved CRM to Salesforce. We moved our HR to ADP. We moved our finance to Intact. We moved our budgeting to Adaptive. We used Rally for project tracking and Concur for our travel. It's not to plug those particular services. They all have competitors and they're all pretty good. The key though for us was that because we couldn't compete in a traditional sense, and in looking at all those services that we were using, almost 70% of our technical people were involved in those systems, keeping them up, keeping them synced. And nobody was paying us for that. And so we were wasting almost 70% of our resources, and only 25% were actually working on products that our customers use that paid us money. So we wanted to flip that around. The key about all of those things is that they were all software as a service based operations. And that's what we did. We moved those out. We reduced our data center footprint from 20 racks down to 2 by doing that. We had to be different, so we took the new approach. We decided to rebuild our app. We revamped our database. We changed our processes. We did everything that everybody was spouting that this is the wave of the future. And well, it didn't work. It was almost a failure completely. But we did learn some things, and it did sort of work. The way that we started off is when it looked like it was going bad and it looked like things weren't going to work out, I went to my boss and I said, let's just do something really, really different. There's 2 guys in a garage that are looking to beat us. They're somewhere, and they're using new tools or using new techniques. They're going to be kicking us in the teeth in a couple of years if we don't do something. So why not go ahead and have them now? And he said, what do you mean? I said, let's take our 3 best people, rent a conference room across town, and tell them they're a brand new startup, go. And their job is in 6 months, come back with ideas that will take us out of business. And God bless him, but Alan Gilmer is our CEO. He said, go for it. We've got nothing left to lose. So in doing this, we kept our old software up and running. We kept it going. And what the first failure taught us was we're actually able to do a lot of change, and we're able to do a lot of things because, one, a lot of that back-end workload we pushed off that gave us resources to do new stuff. But it taught us that we could go and do changes and still run our business. And that's incredibly freeing when you're looking at what you're doing. So many times we can't make a change because we can't afford to drop the balls that we're trying to juggle now. We learned to accept change. You didn't need to be afraid of it. And fear was probably one of the biggest things that was holding the company back and a lot of individuals, and it's held back a lot of other companies I've worked at too. What we learned was this could be a tool that we could use to be different. And if you're in a market where you're the small guy against lots of big guys, being a differentiator is the way to win. It's the only way you can. We had to be able to do things that our competitors were going to be afraid to do. The biggest difference for me was we had the epiphany of we had to stop trying not to fail, and we had to try to win. We had to try to succeed. I started out my life in the Air Force, and there was one thing that I learned back then was that you never went in planning on being on the defense. You wanted to be on offensive posture. Sometimes your offensive posture is a little poor, but you're always on the offense. And this is what we needed to be. We needed to be trying to win, and that meant we were going to do changes, and some of them weren't going to work, and we didn't need to care about it. We just needed to keep going. So we decided to act like a startup even though we were already 13 years old. We had to solve our growing data needs. This was problem number 1. I couldn't do it by continuing to buy traditional storage. We weren't that big of a company. I couldn't keep buying yet another NetApp array or another EMC or SAN. It was getting too cost prohibitive. And as our footprint was spreading around the world, trying to do the syncing of all that data was really becoming problematic. I don't know if you've ever worked or been in Austin, but it's fairly well known, I think, that it is the second highest IPO place outside of Silicon Valley. That means it's extremely difficult to hire engineers, system architects, and programmers. We get the competition from both ends. There are big companies there, and there are also small companies. And it's actually tougher to compete against the small guys who just want to hire 2 or 3 people and throw a million options at them for yet another mobile app that's Uber meets something. We hear the pitches all the time. So we started looking at what we had, and we decided to break the infrastructure apart. The first time around, we broke it apart in a classic sense. We had an ingestion process, a data layer, and an application layer. And what we discovered was that was okay, but it was still about 10 years behind where we needed to be. So in doing that, we looked at all of our storage, and we determined that we really needed to divide up how we were using that storage and make it configurable. And in some places, I didn't need the high-end hardware that I had in other places. Maybe in my main data center with my core data I did, but in other places I needed it to be more flexible. So we moved to software-defined storage applications that I could run on lower-end hardware than, say, an expensive NetApp or EMC type of thing. And I know there's someone here from Supermicro, God bless you, that worked quite well for us. We went to software-defined firewalls and routers and other things. And why did we do this? Because we moved our entire production system into AWS, into the cloud. This was a big move for us. We still had our back-end data manufacturing piece with all the ingestion and the data cleanup, but our production, what was customer-facing, we moved out into the web services and into the cloud. And why did we do this? One, we needed to be flexible. That was our key goal. By moving them into the cloud, certain things became available to us that we could not quite get accomplished for the same price point in other ways. For example, setting up a disaster recovery site. I could either find another data center in another city and work with syncing all this massive amounts of data, or I could simply push it out into 4 regions in Amazon, and I don't care if one goes down, it'll just fail over. We automated our build environments by utilizing some of the tools that Amazon has and a lot of the other tech that's out there, like Chef and Docker and those types of things. We were able to do our builds in a much more automated fashion. We then continued breaking our applications apart, first into multiple layers and then into services. And then we took all of those services and we wrapped them in APIs. And then we started using those APIs to write our apps. So we became the first big user of our own stuff. That gave us an advantage in that before anything went out the door, we already knew whether it worked right or not because we'd already eaten our own dog food at that point. We hired really smart people. That's an obvious thing to do. Some of these are scary smart people. When we brought in a group out of Denver, I don't think any of them had after their last name didn't end in PhD something. And their first test of me when I went to talk to them was, they said, yeah, we're going to meet down in the Hilbert transform room, which if you've taken advanced math, there's the Fourier, Hilbert, and all these various mathematical transforms. Except they don't label the conference room Hilbert and Fourier. No, they put the mathematical formula on the door. So that was my first test, and thankfully they picked the one room I actually remembered half the formula, so I found it. The tough part was people who didn't see the path that we were going down, we had to let them go. And that's never easy. It was really hard, and a lot of those folks were our friends. And when I say we had to let some of them go, some of it was voluntary, some of it was amicable. But to rattle off, that included our CEO and president, our CFO, our CTO, about a third of the programming staff, and our CMO. It was a radical change for the company. But we did it in such a way that instead of just giving them a pink slip and saying, thanks for having you, we worked with them so that our CMO and our former CEO, CMO, CTO, and COO, and president all actually come back and do contract work for us. So it was a very friendly thing. So we still get the benefit of their historical knowledge, but they could see that where we were going wasn't a place they could take us. How many people here have a project management or product management office? Yeah, we got rid of ours. And I'll explain why. It was a traditional PMP certified project management. As a SaaS-based software company, developing and deploying and doing things rapidly is the key to success. And what we found was inside of our PMO, most of their processes were actually there in order to slow things down, to avoid failure. Again, they were just trying not to do something wrong. They weren't trying to win. And we had to change that mindset. And so we totally revamped that. We just went, we were already developing on an agile methodology. We just spread that across the whole thing and changed all the PMO into Scrum Masters, actually. We also discovered that there were lots of people in our company that had really great ideas. But because there had been such a culture of trying to avoid failure, they weren't talking about them. They didn't want to bring up an idea in case it failed. So we had to change that mindset. It's okay to fail. At least you tried. I'd rather try 10 things and get 4 wrong and succeed on 6 than only try 2 things that I'm guaranteed to do. I'll be 3 times ahead the other way. This allowed us to do something that I thought was really powerful. It allowed us to quickly decide to do something, but probably more important, quickly decide to stop doing something. When things were open, when people could see what was going on, and when they felt empowered, they could actually stop whenever we were doing something that wasn't going to work. We probably have all been on that project that was a death march, where everybody on the team knew this project's not going to make it, but nobody would stop it. It just kept going. And we realized we didn't have that time. We didn't have that luxury. For me personally, I learned to shut up. I had spent my entire career being the technical guy, the answer guy. I was the one that was going to go in and fix something if something broke. And what I realized was I really needed to stop answering those technical questions. What I really needed to do was ask the technical questions, even if I thought I knew the answer. And I found that when I gave these discussions with my team and I would say, well, did you think about this? Did you talk to so-and-so? How did you handle this? What's your opinion about what we should do here? I started noticing people were answering those questions and they were getting better at it. And I knew I had won when I was around the corner in the hallway once and I heard 2 of the other folks talking about a project and they said, well, have you run it by Kuvion yet? No, not yet. I need to talk to Bill. I need to talk to Mary. Well, why are you going to talk to them? Don't you want his approval first? Well, no, if I go in there and talk to him, all he's going to do is ask me if I talk to Bill and Mary, so I may as well do that first. And I knew, yes, one less meeting, and by the time I have the meeting, he will already have figured out what to do, and it'll be a short meeting, and that's great because I hate meetings. I realized I had a lot of people that were a lot smarter than I was, and as egotistical as I am, that was hard to swallow, but I learned it, and they still tease me about it. That led us into, once you discover that you've got all these really smart people and you've broken all of your tasks up into really small things, you can then form teams around those small tasks. And what we did was instead of large-scale projects that had 10, 20, 30 people working on them, we broke them into very small projects of 3 to 6 people, no more than that. Yes, they could all come together as a big concept or a big product at the end, and it required coordination. But we took on a kind of philosophy of, for those that have ever looked at military history with the Army and the Marine Corps, they have this concept of little groups of paratroopers. If they're going in for an operation and it's going to be an airborne type assault, every member of that team is briefed on what the overall mission is. And then they're given their specific roles. And everybody has a plan and it's all well thought out. And as soon as you engage in that plan, it all goes to hell. But each little group knows what the overall objective is. And however their world has changed, they still march to that same goal. And it may not be the same path they originally planned, but as long as they're all marching toward that goal, even if a couple of them get lost, you end up getting there anyway. And that's how we wanted the teams to work. We wanted them to have the authority and the ability to do things. One simple trick that we did was we mandated that you had to deliver something of value at the end of every sprint. For our developers, a sprint is 2 weeks. And this had a profound effect on the team. They had done sprints before, but they didn't always have to demo something. They didn't always have to deliver something of value. And so what you really got was a 3 or 4 month effort that was just kind of divided into 2-week things. And that didn't work either. What we wanted to show was that we could actually demonstrate the ability to deliver value on a fast pace. In fact, it had to be good enough to demo because I was not going to announce when I was bringing a customer in to see something they were going to show off. This initially had the effect of scaring the hell out of them, but then they got to look forward to it, because nothing is more motivating to a group of engineers and technical people than to have a customer saying, what you're doing looks really, really cool, and man, if it could just do this one more thing, I'd buy it tomorrow. I have had customers say that on a Friday, and the team volunteer to work all weekend long to get it to them on Monday without my asking, because they were that motivated by it. This allows them to get really, really creative. When they start talking to customers, they start finding out that customers will often ask for ability to click here, I want this, add this. The technical people are smart enough, okay, that doesn't make a lot of sense to me. What are you trying to do? What are you actually trying to accomplish? And then the customer will sometimes, well, what I really need is this. And they explain what that pain point is. What's that thing they're trying to solve? What's the question? And once they pose that question, now they've got a room full of really smart technical people thinking about how to solve that. And they will solve it in a way you've never thought of before. And that opens up their creativity. For those that have had to manage technical people, you'll realize that many of them are musicians, they're artists, they're heavy into those things, because I think the programming brain and the artist brain is a lot the same, except they just don't have quite all the social skills of a lot of the artists. Really smart people will find ways to automate mundane tasks, and a lot of our work is very, very mundane. And there's a really good reason for that. You're kind of lazy. And that's okay, because a really smart person who's kind of lazy will help figure out how to do something as fast as possible, especially if it's boring and mundane. So back to moving our production system into AWS. When we first did this, we did this way that a lot of people traditionally will think of it, and that is we moved servers that were once hardware and chunks of iron in our data center, and we virtualized them and we pushed them out to AWS. And we realized while that can work, it's not the best way to do it. We had to really fundamentally rethink it. So in part of breaking down those apps and breaking them down into services, and then breaking the services into microservices, and then wrapping them in APIs, we were able to leverage a lot more of the tools. In fact, if you treat cloud services like you do your data center, you will fail. And I don't mean you will fail in that you'll get something done, you'll probably accomplish the task, but you'll miss the boat on taking advantage of what those services actually can provide you. It's an order of magnitude more rapid delivery of value to your customers. Think about it. What they're really doing is it's somebody's hardware that's running an operating system that's emulating hardware that you're installing an operating system that you then run an app on. And that's insane. That's the kind of stuff that makes God angry in terms of how you would go about doing things. So that's why we looked at breaking those things down to microservices, because when you start thinking small instead of large applications and large products, you start gaining those efficiencies and you start doing those small things faster. And you start adding up those little pieces, and then they can start communicating a lot better, and you can automate those things a lot better. There's tools out there, Docker, Ansible, Chef, Puppet, there's a few others. Make those kinds of tasks really easy to do. And the smaller and more focused your little microservices or apps are, the easier these things are to do. So today we can deploy our entire production system in under 20 minutes in one or more Amazon regions. That represents roughly 80 servers on the web front end, about 40 database servers on the back end. It fluctuates. We do have auto scaling, so it depends on the demand. We're doing that with the same 3 CM people we had 2 years ago. 2 years ago, they could only deploy 2 servers in half a day because somebody had to go out to the data center, they had to rack and stack the hardware, they had to install an OS, and they had to go on. So that's what I'm talking about in terms of increasing your ability to do things. We've now revamped our architecture yet again. Now that we've got everything wrapped in APIs, we're looking at the container-based systems like Docker. We're going to be rolling that out here in the next couple of weeks, and that's going to actually increase our ability to do one more thing that I like that gives us a lot of flexibility, and it means we'll be able to deploy our entire production system to any of the cloud-based services with minimal change other than configurations to the environment. So I can deploy to Amazon, I can deploy to Microsoft, I can deploy to Google or Rackspace. And again, a lot of flexibility. I no longer care which one of the services that's out there. So it's going to be more about what I need. If I have more customers in Indonesia and I need to get a server out there and only Google plays out there, we can do it, and it's not any more workload than doing any other part of it. It's not all pancakes and unicorns. It is easy to screw these things up. If you're not monitoring what you're doing, if you're not paying attention, if you try to treat it like you do normal data center operations, you can run your cost up. It's very easy to do. You can fail as fast as you can succeed, but I actually think that's also a benefit, as I mentioned earlier. You do discover those failure points quicker, so you stop doing something bad sooner. Like I said, it's not easy. It can be harder than a lot of what I consider the old ways of managing those old IT systems, but it comes with a lot of advantages as well. You can move a lot faster. So I'm going to briefly go over the kind of points, and then I'll open it up for questions. Don't waste key resources and stuff people don't pay you for. It seems simple, but that's really what it boiled down to. If given a choice between hardware and software, choose software. What do I mean by that before all the hardware guys out there throw things at me? What I mean is if you don't need it, if it's something that can be virtualized and done in a different way, choose the software path because it's easier to automate than it is the hardware path. Breaking your projects into small teams is better than big teams. I'll talk about a couple of results that happened to us when we did that as well. One of them was the changing of how we did our database crunching. And this is where we did use a high-performance machinery. It's around Elasticsearch, if any of you guys are familiar with that. But we had a challenge of having to take all of the production records for all of the wells in the United States going back to at least 1936 and being able to do a Beekline type curve and project that in a browser on screen in under 15 seconds. The best high-end dedicated workstation software that we had that ran on a 32 gigabyte machine with quad-core processing couldn't do it in under 2.5 minutes. So we were trying to figure out how do we do this in a browser window, because we're SaaS-based and it's got to be in a browser. By using Elasticsearch and some of the server-side crunching and separating out what we knew to be core data and what we call our core queries that we were able to pre-calculate and do some things, we were able to spread the calculation of what's the new data, what's the delta of the data off of the core. We actually spread that out amongst the clients. So every user actually asking that question became part of the computing thing. So it was really kind of a distributed computing along with the back-end cluster, so that we were able to actually deliver all of that production record data in a type curve in under 15 seconds on a browser. No one else is doing that, and we're launching that product this week. The product was conceived at the end of February. The team was put together in the middle of March, and the development was through April, and we're shipping it in mid-May for something that wasn't even thought of when we started the year off. Don't treat cloud services like AWS like a data center. Really look at the services, learn what they do, and look how it can apply to what you're trying to do. If people aren't on board, let them go, no matter how talented. One of the hardest lessons I've had to learn as a technical manager is what I refer to as the tyranny of technical competence. It's that one guy or gal that is really, really good at their job, but they just don't play well with others. They might be able to produce 120, 150, 200% compared to the other folks, but if they're dragging everybody else down on the team down by 50%, you have to let them go and move on. Don't waste all your energy trying to avoid failure. As I said, we went from about 70% of our people working on things to try not to fail to flipping that around to only 25% are really concerned about, is the circuit up? Do we have the uptime that needs to be there? Everyone else is working on a new idea. Listen to the smart people. That's why you hired them. If you have people on the team that you know are good and you've got them on board and they haven't given you a good idea, ask them why. Either they're not as smart as you thought or they're being held back by something and you're missing out, you're losing something. And then understand that most of the time you aren't one of the smart people. You have to listen to your folks. You're too busy doing other things. As one of my managers told me, the reason they engage with me is because, say, boss, you have that 10,000-foot view. Sometimes I don't know what's going on in that other department, and I can ask you to give me that high-level view to know if I need to go find out more. He said, just keep doing that, because if you try to get down in the weeds, you're going to miss all that, and that's worse. So that's really all I had. I'll open the floor to questions. Sir?
So at the beginning of your talk, you discussed that much of the data that you're collecting is public information. Then you went into the individual oil companies that are hiding information from each other. If everything's out on the cloud, how do you level this between these? I mean, if it's in public information, I can find it. If it's in private, I can't. It seems like your sweet spot is to bring that together, but how do you really do that?
Are you asking how we actually bring the data together?
Well, I understand how you bring it together, but do you have, I guess what I'm getting at is, do you have, do your sources of information cause grief to you?
Oh, absolutely.
I mean, how do you get around that?
Yeah, I should have spoken more when I talked about the dirty data. The public data is all data that is filed with courthouses in every county in those 22 states that produce oil and gas data. The most advanced courthouse that is online that you can go search is the Railroad Commission in Texas, followed by North Dakota. About half of the counties in Texas have enough electronic data that they can contribute to that central database. The rest is all paper. The data that is reported by these companies is reported for the basis of being taxed on that information. So they're not really incentivizing those oil companies to report all of the data or accurate data. Again, why it's dirty. Part of what we're doing in our analytics is we compare all those different sources to make sure that, hey, wait a minute, you said you had 10,000 barrels of oil here, but you shipped 12,000 last week. What gives? In dealing with those county courthouses, every county clerk is like their own little king or queen of their little empire. And we have to deal with things like they will not allow you to photocopy the papers. They will let you take digital photographs, 5 maybe, at $1 a piece. And you have to deal with that. And it's a lot of socializing, getting to know them. There's a whole industry in the oil and gas industry that's called landmen. And all they do is go to courthouses. And they develop relationships with people in the courthouses so that they can go down into the basements and look up title deeds and liens. And we bring all that data in. Usually we get it either as photocopies, microfiche, or raw paper, and then we have to process that. You also mentioned company data that they only share 1% of it. That is true, though sometimes you do get lucky. For instance, in our case recently, we had Amico, after they were purchased, gave us their entire data library going back to the 1950s. Just donated it to us. The paper versions, not the electronic ones. I still have to get that converted. But data's data, and we'll take it. Did that answer your question?
Yeah.
Any others?
Yes.
Can you give us some examples of the size and scale of some of your workloads?
Some of the workloads. We take in leasing data from all over the country. These are in terms of who owns what land, essentially. There's a little over 2.5 million of those records that have to be processed a day. Each one of those leases is about a 10-page document. So that has to go from typically a PDF format all the way into the database, and we have to get that processed within a 24-hour period. That's just leasing. Production records is on the order of 16 to 18 million, depending on what's going on in the market daily. We have most of that automated now. On average, it takes, we spend about 0.06 hours per paper document. Except for production records, it's down to about 0.006 hours because so much of that is now automated.
Yes.
Can't see.
Is it easier to hire the quality and qualified employees now you've switched your model?
Yes. What I have found is, particularly with the technical folks, they will, you have to pay them a certain amount. You know, there's that certain amount that they're going to be happy with, and then after that, it's non-monetary things that matter to them. And for the technical folks, the things that motivated them the most were, is what I'm working on cool, neat, and futuristic? Who else am I working with? Are they experts? Can I learn from them? And what sort of training am I going to get? There's the old joke, and I've actually heard it between our CEO and our CFO. Our CFO was saying, well, why should we pay for the training? What if they leave? And the CEO said, well, what if they stay stupid and stay? And it's like, that's worse.
Yeah, 1 second.
So you mentioned that a big turning point for your company was farming out services that were not part of your core competencies.
Mm-hmm.
And so I imagine that when you guys are running the numbers on that and projecting project savings, they don't necessarily work out right away because you're sort of projecting numbers that you really have no idea about because it's a business model that you're not really familiar with. And so I'm just wondering really if you could list some characteristics of your company that sort of allowed that to pass through, whether it's company culture or the people there, how you sort of push through that idea of moving towards something that wouldn't necessarily immediately give you project savings, but would be better for you in the long run.
Yeah, it was actually easy in one respect. Now, one, we were a SaaS company. So I just went and convinced the head of sales, and then I had him make the pitch with me because it's the same story we were telling our customers. Do it with us because as a SaaS-based company, we can deliver better value to you. That's the same thing we were trying to do with these back-end systems. Yeah, the CFO wanted an ROI inside of 6 months, a year, and you just tell them, it's not going to be that. It's going to be a little more expensive up front. Because what you're really doing is you're freeing up all those resources that were tied up supporting those things. You still inherit an integration cost. It doesn't come free. You still need to integrate your Salesforce system with your finance system and so on. But you can contract those out because those tend to be somewhat short-term efforts, and then you go into maintenance, and you need a smaller staff for doing that than trying to do it yourself. The ROI really starts coming when you can divert those resources in developing new product. So to give you an example, at the end of 2011 when I joined Drilling Info, they had essentially 2 products. Today we have a little over 30, and we're kind of tapering off there. in terms of full-on products. What we're doing now is we're adding a lot more value-add features or modules to the things. In fact, the last two products, we didn't actually write any code. We just restacked different modules together that had never been combined before. So now developing a product is even cheaper. But because that happens over a 3 or 4 year period and you're mixing up all those things, it's hard to prove that. But it's the whole argument behind being a SaaS-based company anyway.
So you mentioned you moved all your services into the cloud. Did you have to make any compromise on the performance when you moved to cloud, or were you happy with it?
Yeah, there was definitely a compromise in performance on database. At the time we first did it, you could do database out in the cloud, but again, if you tried to do it like you do a typical data center where you're just going to stand up a virtual server, virtual servers typically don't work well with I/O in those scenarios. A lot of the newer services now, you don't actually order an instance. I met with Amazon last week. What you now go in and do is you order a certain amount of IOPS or a certain amount of throughput, and then they scale up on that side and you pay for that. So it becomes easier to build your app when you know that. So initially, that's why we did not move a lot of our storage into cloud. And in fact, I would argue that it's still not quite cost effective to do so. Not on the raw storage itself. Once you get it there, it's cheap to keep it there. It's the transfer. And because I have the problem of none of my data ever ages, I've come from industries where you always had to have a certain amount of data that had to be fresh and active, but you had data somebody hardly ever touched and you could put that on slower storage. That doesn't exist with oil and gas. That survey taken in 1875 is just as good as the survey taken last week, and they will go pull those up and use those.
Do you use any machine learning techniques, and what is your machine learning strategy if you use so?
Yeah, we use machine learning techniques. In fact, we just did an experiment with Amazon on their new machine learning systems that they put out, which are actually okay. They're pretty good, but they're missing two key algorithms that we like to use. We utilized machine learning on analyzing leases, particularly old handwritten leases from way back when. There's a phrase in most leases that is called a PUGH clause, P-U-G-H, which indicates how deep that mineral lease goes for. So you can have, on the surface area of land, you can have multiple owners, but they own different depths of those mineral rights, which matters when you're drilling down there. The problem is there is no set legal language for what defines a PUGH clause. It's just one of those things that a landman who's been doing it for 25 years or a lawyer just can look at it and tell that's what it is. So we sat down with a set of machines and landmen and just started going through a few thousand examples and just having them, this is a PUGH clause, this is not, this is, and training up an engine. So we now use that to pull out the PUGH clauses on those leases. The other area that we did machine learning on was because of these leases get taken out and done at different depths over different times, if you try to map these on say like Google Earth, you get a lot of overlap. And when you actually unstack, you can see there's like 10 leases over the same piece of land. Because if grandpa had 300 descendants, or great-grandpa had 300 descendants, you may have 20 of them gave a separate lease for different royalty payments over the same land. And that has to all be counted. Well, one of the things that oil companies are constantly trying to do is see how much land does my competitor have tied up in this area or this county. Well, if you just go and count the leases, you're going to get highly inflated numbers because you're going to be multiply counting the same thing. So what we had another product that we developed called Land Tracks, which actually tracks all these mineral tracks. By using machine learning to overlay those with known drillers and oil wells and who owns what wells, and combining it with a third data set, we were able to define and lay out to within about 2% accuracy of what the companies reported themselves. Only we were able to do it. It took one guy about 3 months once we had the algorithms built.
This will be the last question.
I had dealt with Amazon on IOPS service model, And it depends on what type of data you're trying to push through your servers. I bogged them down. My data was too big. It wasn't like BB size, it was tree trunk size. So even with the biggest IOPS I could get, I had the right servers, I had the right data, I just couldn't get it to communicate fast enough.
Yeah.
So,
Yeah, we're looking at, we have a problem with transformations. The typical ETL processing doesn't work well with them. So we're moving now to trying things with a Kafka bus and Sparks to do a lot of our transformation. And what that's done for us is on our data, at least with those transformations, it's really cut down on our IOPS. And so that's one thing that we're looking at. Kafka is a message queue that runs significantly faster than any others I've seen.
Ladies and gentlemen, please help me thank Michael for a great opening keynote.
Thanks, everybody.